All right, hello, lovely humans. Welcome to part 2 of how to do derivative calculus. Yeah! All right, so calculus gets this bad rep that is very challenging, but what I want to point out is that at a certain point, we all had to learn new rules in mathematics. We were not born knowing what these symbols mean. Whatever. So, there's a lot of symbols in math, and I totally understand that that can be very daunting. But we also were not born knowing what these things were or how to shape them or sound them out, whatever. You get it. So we have had to learn the meaning of symbols in so many different ways, and calculus is just the exact same thing. If you've ever had to learn a second language, you'll know that to speak a second language and to read it fluently, it takes practice. And so calculus is the exact same way. It can be easy when you find the right teacher. So that's why I'm doing this, is I'm hoping to bring a little bit of understanding to calculus, and just let you know that anytime we do something for the first time, it's going to be challenging. So if you're trying to learn calculus, whether you're in school or you're beyond school and you're like, I've always wanted to learn calculus, just know you absolutely can. And just remember that persistence and practice are key. You can do it. I know you can. And I am here to help you along the way. So please let me know if there are any particular issues that you have in calculus, if there are types of problems that you're struggling with, and I'd be happy to talk to you about the concepts. What I won't do is solve the problem for you. I'm one of those teachers. We can talk about the big picture and how to go about solving problems, but you gotta do your own homework, because that's how you learn. You're not gonna learn French if you have someone else speak it for you, right? Okay, so in video 1, we looked at derivative calculus on kind of a higher level picture, and then we used it with the power rule. I almost call it the product rule. Too many P's. So in this video, I'm going to briefly mention the power rule, but then we will dive into more complex derivatives, including the product rule, the quotient rule, the chain rule, and I'll cover a couple of common types of derivatives. When you have functions like sine of x, there are a lot of specific types of functions, and at a certain point that just requires enough practice that it gets burned into your brain. But if you do it enough times, you do it 20 times, you will have no problem. And let's be real, in most cases, we don't actually have to memorize these things because we can look them up. Yay, internet. Okay, so the first thing that I want to point out is that when I say a function, I mean something that looks like this. So we can read this as f is a function of x, where x is our variable that can change over time. So I'm going to write two types of functions. I don't know, I'm just going to pick one, ax squared plus bx plus c, where a, b, and c are constants or just numbers. I like to talk about things generally. So this is definitely because I did physics, where physicists love to work through problems without any numbers or as few numbers as possible. There's only one number in this equation. But these are stand-ins for numbers. What I like about this approach is that it allows us to focus on the understanding of reading the math versus solving a specific problem. Once you understand how the symbols work, you can easily plug in numbers later. I have to admit, engineers kind of do the opposite. Engineers love to plug in numbers way early on. So when I got into engineering, it was definitely a thing that I had to learn and get used to. But when I teach math, I like to take the physics approach because I think it's a really good way to understand mathematics. Anyway, I get sidetracked because I love math and I love explaining it, and I want you to understand why, and also I'm hoping I'll plant that seed in you too. Okay, so we have our first function of x, and then let's say we have another function of x that looks like, I don't know, we can keep this simple, so we'll just do cx plus k. All right, whatever. Doesn't really matter. These are general functions. But we have two of them, and let's say now we want to take the derivative with respect to x of f of x plus g of x. Oh my gosh, that's so much work. It's okay. It's really not that bad. This one is called the sum rule. I think. Haha. I'm giving it that name because you're summing these two functions. I look on my notes and I'm like, I didn't write it down, but that's fine. Okay, so I'm not actually going to take the derivative of this because you can apply the power rule to both of these. And the power rule, again, is just d dx. Can y'all see that? Okay, sort of. D dx of, here, let me write it somewhere that's easier to see. Okay. D dx of ax to the n equals n times a times x to the n minus 1. So you can apply that to each of these terms individually, and if you don't have an x, then it goes to 0, because a constant doesn't change over time. So when we take the derivative and we're asking, how is this thing changing? A constant's like, well, I'm not changing. So if you were to plot, for example, a constant on a graph, it would have a flat line. And so you would say, oh, it doesn't change over time. It is always constant. Ha! That's where the name comes from. So the derivative of a constant is 0. I'll also write that down. So d dx of, a equals 0. So in this case, the sum rule is super straightforward. You just take the derivative of each of these. So d dx, and you add them together. F of x plus d dx of g of x. Okay, and so now my lazy physicist brain is like, ugh, in my hand is like, too much writing. Why am I doing all this writing? Look at all these d dx's. My goodness, can I write this simpler? And the answer is yes. There are actually a lot of different ways to write derivatives. This is the most common and introductory calculus, but once you get beyond that, what you will find is typically the prime notation. So it looks like this. So, oops, that's supposed to be a plus g prime of x, where that's that. So prime indicates that you have taken the derivative with respect to x of this function. And so instead of having to write all of these symbols over and over and over again, you just add a little prime, which is super cool. It also is really handy when you start getting into second derivatives and things like that, because if you were to take d dx of f prime of x, what you would get is f double prime of x, and that tells you that you have a second derivative. So this notation is really useful in higher level mathematics, physics, engineering. Oh, I lost my eraser. Oh no. Because it just is very compact and it allows you to build things up a lot more. Okay, so that is the sum rule. I'm gonna grab my eraser 1 second. Okay, and I come back. Okay, hello. Oh, good times. So I'm going to erase this part and just write f prime of x plus g prime of x. Okay, so that is the sum rule. Again, I didn't write the name of that on my notes. Okay, what about the product rule? So let's say you have d dx of f times g. So f of x times g of x. And let's be real, we want to be lazy. We don't actually want to multiply these two functions together because that would be way too much. Too much work. Let's keep this simple. Especially because when we do derivatives, we're going to lose some of these things. The constants are going to go to 0, so we can save our time and just do the derivative first and then plug in our functions later. So the way that this works is that you take the derivative of the first one and multiply it by the second, and then take the derivative of the second one and multiply it by the first. And that looks like this. You have f prime of x times g of x plus f of x times g prime of x. That's it. You just add those two together, then you can plug in, so you could do this individually. So what I'm going to do is I'm going to run through this example really quick, and since this video is getting a little long, I'm going to break this into another part. Okay. So to keep your attention span, I totally know how it goes. Okay, so what we can do is first f prime of x, we take the derivative with respect to this function, so we go piece by piece. So using the power rule, the derivative of this first term is going to be 2ax. The derivative of the second term is going to be plus b, and c goes to 0. I could just say plus 0 if I want. And then g of x is going to be, the derivative of cx is just going to be c. And k goes to 0. Rad, right? So these are the two simpler terms, and you can see that it is way easier to multiply these two together now. Because if I wanted to do the full product rule, I just multiply f prime of x by g of x. Now I only have 2 terms times 2 terms. My life is way easier. And then I multiply f of x, this one, by g prime of x. So in that case, it's way easy because g prime of x only has 1 term. Huzzah! So that I could do in my head. So that, dear viewer, is your challenge. I want you to find the final result for the product rule for these two functions. Cool. So once you've done that, go ahead and watch part 3, and we will cover the quotient rule and the chain rule and a couple of special functions. Yay!